Triton, a frozen orb of nitrogen ice, might harbor a hidden ocean beneath its icy crust. This intriguing possibility is fueled by evidence of geologic activity, including geysers erupting from its surface. These geysers suggest a warm interior, potentially keeping an underlying ocean in liquid form. But life on Triton, if it exists, would face immense challenges. Its surface temperature plummets to an astonishing minus 235 degrees Celsius, making it one of the coldest places in the solar system. The extreme pressure and darkness of a subsurface ocean would also pose significant hurdles. Additionally, Triton's orbit is unique. It orbits Neptune in the opposite direction of the planet's rotation, a phenomenon known as retrograde motion. This suggests a violent past, possibly involving a collision that sent Triton into its current orbit. Such a tumultuous history could have sterilized the moon, making it inhospitable to life. Our knowledge of Triton is primarily derived from a single flyby conducted by NASA's Voyager 2 spacecraft in 1989. Despite the wealth of data gathered by Voyager 2, many questions about Triton remain unanswered. Scientists eagerly anticipate future missions to this enigmatic moon. However, there does not seem to be any mission planned in the near future. So, we will have to wait longer to get useful data on this distant and frigid moon. The largest asteroid and smallest dwarf planet in the solar system could be home to liquid water, sitting deep underground. Once considered a mere asteroid, it has captivated scientists with the intriguing possibility of harboring life. Our knowledge of Ceres has been significantly enhanced by NASA's Dawn spacecraft, which orbited the dwarf planet from 2015 to 2018. Scientists are still unpacking and analyzing that data, but tantalizing studies in the past few years suggest there's an ocean sitting 25 miles below the surface and could stretch for hundreds of miles. It would almost certainly be extremely salty, which would keep the water from freezing even well below 0 degrees Celsius. Dawn even found evidence of organic compounds on Ceres that could act as raw materials for life. While the potential for a subsurface ocean is exciting, Ceres faces significant challenges for life. Its small size and lack of a substantial atmosphere make it difficult to retain heat, and the surface is exposed to harsh radiation from space. Additionally, the asteroid belt environment is filled with debris, posing a constant threat to any potential life forms. There's no shortage of new proposals for future missions to study the dwarf planet, but nothing is going up soon. Io, Jupiter's innermost moon, is a world of extremes. With over 400 active volcanoes, it is the most geologically active world in the solar system. The incredible volcanic activity on Io is primarily driven by tidal heating. As Io orbits Jupiter, the planet's immense gravity flexes the moon's interior, generating friction and heat. This process is responsible for the constant resurfacing of Io's landscape. The volcanism results in a huge coating of sulfur and sulfur dioxide frost across the globe, along with a super thin sulfur dioxide atmosphere. There might even be a subsurface ocean on Io, but it would be made of magma, not water. Life on Io is very unlikely. But all that heat is a bit of an encouraging sign. There may be locations on the surface or underground that aren't overwhelmed by the volcanic activity. More temperate places where hardy forms of life have found a way to survive. We wouldn't be able to study those spots directly, but a probe might be able to find evidence of life if it gets lucky. To unravel the mysteries of Io, NASA has proposed the Io Volcano Observer, IVO mission, which if approved would launch in 2029 and do 10 flybys of Io. However, the likelihood of it happening is low, and hence, studying this fiery world will have to wait longer. Callisto, one of Jupiter's Galilean moons, is a world scarred by time. Its heavily cratered surface tells a story of ancient impacts, making it one of the oldest-looking bodies in our solar system. Despite its ancient appearance, Callisto harbors secrets that could reshape our understanding of planetary evolution and the potential for life beyond Earth. It's another moon that's thought to have a vast subsurface ocean, 155 miles underground. It also retains a thin atmosphere of hydrogen, carbon dioxide, and oxygen, which is more diverse and Earth-like than most of the other solar system moons that could be habitable. Due to its relatively low radiation environment compared to other Galilean moons, Callisto is considered a prime candidate for future exploration. Our next best chance of really exploring it will be the European Space Agency's Jupiter Icy Moon Explorer, launching next year and set to explore 3 of Jupiter's moons. JUICE will make several close flybys of Callisto during its mission. Ganymede, the largest moon in our solar system, orbits Jupiter as a colossal icy world. Its size surpasses even the planet Mercury, making it a truly remarkable celestial body. Beyond its impressive dimensions, Ganymede holds intriguing secrets that could redefine our understanding of planetary evolution and the potential for life beyond Earth. Ganymede is a dichotomy of extremes. Its surface is marked by both ancient, heavily cratered terrain and younger, smoother regions. This suggests a complex geological history shaped by a combination of impacts and internal processes. Beneath its icy crust, Ganymede harbors a vast subsurface ocean, a potential habitat for life. And Ganymede has something else no other moon in the solar system has: a magnetic field. A magnetic field is critical for protecting worlds from harmful radiation spewed by the sun. But Ganymede isn't perfect. A subsurface ocean is difficult to study. So if there's life on the planet, we're going to have a difficult time finding it. And so far, there has not yet been a dedicated mission to study Ganymede, although the JUICE will be the most in-depth investigation of Ganymede when it enters the moon's orbit in 2032. It may have an opportunity to peer down at the surface and study the interior using radar, and clue scientists into Ganymede's potential habitability. Our solar system is brimming with potential habitats, but to do them justice, we need more time. To avoid making this video too long, we'll continue our exploration in part 2. Stay tuned for the next installment by subscribing to our channel so you don't miss out.